Tell us your name and tell us about your project.
Dr. Robert Oppenheimer. I served as the director of the laboratory in Los Alamos, New Mexico, which opened as part of the Manhattan Project. The Manhattan Project started to develop atomic weapons. The laboratory in New Mexico was responsible for the functional design of the bomb.
What were you guys trying to do or find?
Like I said, the Manhattan Project's goal, its aim, was to develop atomic weapons. We developed the functional design of the atomic weapon in New Mexico. Other labs worked on other projects such as uranium enrichment and the production of fissionable material.
Where did the project or experiment occur?
It occurred all over the United States and in several allied nations such as Canada and the United Kingdom. It was headquartered in Tennessee, but the project I worked on was in Los Alamos, New Mexico.
What other significant events were happening around the world at the time?
Well, World War II was underway, and several German physicists, or even other European physicists in fascist nations, had fled Nazi Germany. Specifically, those of Jewish heritage had become concerned with Nazi ambitions to develop atomic weapons themselves. Albert Einstein penned a letter to President Roosevelt in 1939, warning him of the potential devastation and destructive potential that could be caused by atomic weapons and of Nazi aims to obtain these weapons. President Roosevelt heeded these warnings, and on December 6, 1941, a day before the bombing of Pearl Harbor, actually, the Manhattan Project began.
Who else was involved in the project?
There was hundreds of thousands of people in all sorts of roles, including physicists and chemists and engineers, primarily in the United States, but also Canada and Brits were involved in the process as well.
What was your role in the project?
I was responsible for directing operations at the laboratory in Los Alamos, New Mexico. New Mexico was responsible for the practical design of the bomb, allowing it to be deployed by aircraft. As part of this endeavor, the New Mexico lab found a way to reduce the fissionable material into a metal that could be molded in the shapes required for the bomb. Additionally, a method of rapidly bringing fissionable material together in order to achieve a supercritical mass and consequentially a nuclear explosion had to be developed as well. Neither of these technologies existed either in practice or in theory prior to the beginning of this project. We were successful in that endeavor, and finally on July 16, 1945, the Trinity test took place 120 miles south of Albuquerque, where we detonated the first weapon. And then, of course, 3 weeks later, we would use these weapons in Hiroshima and Nagasaki to bring about the end of the Second World War.
What impact did your project have on the physics community?
Well, the Manhattan Project successfully harnessed nuclear power, though for destructive purposes. But the atomic bomb led to public knowledge about the existence of nuclear forces. In the scientific community, specifically the physics community, the development of an atomic bomb helped spur on the development of nuclear power and nuclear technologies. Today, for example, nuclear power is responsible for 15% of all power generation on Earth. The Los Alamos laboratory is still in use today, as well as several other labs that were built as part of the Manhattan Project are still working. The work in Los Alamos came up with several discoveries and raised previously unthought of questions. At the time, the number of neutrons emitted during nuclear fission with fast neutrons was unknown, and determining critical mass was also unknown at the time, and both of these questions had to be answered prior to the construction of a bomb. The work at Los Alamos, in many ways, was more technical. It didn't seek to answer fundamental questions, but technological ones. Technologies such as electronic equipments that could measure time in microseconds had to be developed as part of the process in New Mexico. And of course, the problems with implosion and metallurgy with the fissionable material were also resolved during the project.
What was the most difficult part of the project?
The most difficult part of the project was the set of problems dealing with the implosion. It required experimental techniques and a branch of physics that no one was really familiar with. In order to create a nuclear explosion, fissionable material that is at subcritical masses has to be rapidly fused together, reaching that critical mass. What we did, we achieved this through the process of implosion, compressing the subcritical masses together into that supercritical mass, allowing for the nuclear explosion.